So we talked a little bit about this before. Sometimes out in the real world we have what are called line graphs, and they give us data, show us information. I mean, you could be in business, maybe you sell cars or something, and you find, oh, at the beginning of the year sales were increasing, and then maybe they leveled off, and then maybe sales went down for a while, maybe they increased again. This is an example of a line graph, okay, where we're saying, here's the number of sales, and then, oops, sorry, not what I meant to put. Here's the number of sales, and here's the months of the year or something like that. So as the year goes by, you might see a pattern or something. Okay, so we have an example here. It says many factors affect whether a marriage will last. Data show that divorce rates are higher for those who marry younger, but education may also play a role in the longevity of marriage. And this graph, by the way, is in your textbook, so you can locate that in the e-text. The line graphs in the figure show the percentage of marriages ending in divorce after 5, 10, and 15 years of marriage for 2 levels of education attainment. Okay, so this blue line is if they have a bachelor's degree or higher. That's couples' divorce rates. And then the red line is if they have no college. Okay? So 2 line graphs all on one grid, so you can kind of compare them and see what's going on. Notice here it's starting at the origin, no marriage, no divorce. And then we're saying along the x-axis, 5 years of marriage, 10 years of marriage, 15 years of marriage, and what's happening. Now on the y-axis, we have the percentage of marriages ending in divorce. Okay? All right. That's the graph. So you want to read all those things on the graph so you know what it's talking about. Now, below the graph, here are 2 mathematical models that approximate the data displayed by the line graphs. So they take the data that they gather and they come up with a model that will approximate the data. Okay? So this is the equation for when there's no college. This is the equation for a bachelor's degree or higher. Now, why my one equation is smaller than the other, I'm not really sure, but sorry about that. All right. In each model, the variable n, they have to tell you what the variables represent. So n, right there in that one, right there in that one, is the number of years after marriage. Okay, so 5 years after marriage, 7 years after marriage, something like that. And the variable d is the percentage of marriages ending in divorce. Okay? So it's going to give it to you as a percent, so maybe 20% of the marriages end in divorce or something like that. Okay, so this is, it's n and d, but n is your x, right? Like that's the x-axis, the horizontal axis, and y is the d, the vertical axis. Okay, but we don't have x and y this time, we have n and d. But they tell us what everything means. Okay, so hopefully that makes some sense. Now, part A says, use the appropriate formula, because you have 2 of them, you have to decide which one, to determine the percentage of marriages ending in divorce after 10 years, so that's going to be my n is going to be 10, when the educational attainment is bachelor's degree or higher. So that means I'm going to use this one, okay? So D, I always like to rewrite it, D equals 1.3 n plus 6. Now I know what n is. We're doing 10 years of marriage. So what's the divorce rate after 10 years of marriage? Okay, so then we have to do a little bit of calculating here. Pull out a calculator or something. But it's going to be 13 plus 6, which is going to be 19. So according to the model, according to the formula, after 10 years of marriage, if they have a bachelor's degree or higher, 19% of the marriages are ending in divorce. Okay? That's what part A is talking about, using the formula. Now, why didn't I use the other formula? Because we weren't in the no college situation. They could have written the problem that way, but they didn't. They just wanted to know bachelor's degree or higher. Okay, so now we do part B. Use the appropriate line graph in the figure. So we have to go back to the picture and determine the percentage of marriages ending in divorce after 10 years. So this is going to be according to the graph that they gave us. And we're still doing bachelor's degree. So same situation. Here we have the model that we're using, and now we're going to be using the graph. Okay, so we go to the graph. we locate 10 years of marriage right there. We're going to read up to the blue line right there. And then we're going to go across, which it looks like it's at 20%. Okay, so you might have to access that picture in your book, but according to the graph, it looks like D equals 20. Okay? Does the value given by the mathematical model underestimate or overestimate the actual percentage? Remember, this is the actual data. My model's just a prediction. Well, it looks like it underestimates. Okay, so the model said it would be 19%, but the actual data says 20%. So what's the difference between 20 and 19? It underestimates by 1%. Okay? And it says, yeah, does it underestimate or overestimate? And by how much? Okay, now that might not be the same if you were to go 15 years. You could redo the problem with 15 years, or you could redo the problem with no college and looking at the red line. So there's all kinds of questions you could ask, but we're just asking these questions and basing our answers on the information that we have. Okay.